Next, we would like to invite our next speaker who flew in from Seattle to be here with us in person today, Dr. William Keepin. He holds a PhD in applied mathematics, oh my goodness, a master's in mathematical physics, a master's in East-West psychology, an honorary doctorate from the California Institute of Integral Studies. He has presented testimonies to European and Australian parliaments and the US House of Representatives. He has published numerous books and written in a wide variety of fields, especially on the intersection of science and spirituality. He co-founded the Sayana Institute to facilitate dialogue and inspirational interspiritual practice across many religions and science. Please help me in welcoming Dr. Keepin as he speaks on Holomovement, science of the interconnected cosmos. Dr. Keepin, please.
So good morning, and thanks to the organizers for inviting me, and thanks to the earlier presenters for these wonderful presentations. I thought we might begin with just a very brief moment of silence. We have so many ideas. Just moving into deep silence for just a moment. Thank you. So I want to talk today about the true nature of our interconnection with one another. Should I hold the mic down? I'm hearing a popping sound. I'll hold it here to try to eliminate the popping. So in science, in quantum physics, it's called the Holomovement. In plain English, I like to call it the Internet of the Heart. The Internet of the Heart, which speaks to the essence of how we are connected to one another and to all of life, that is now being revealed at the cutting edge of science and spirituality. So I heard a talk from the Dalai Lama about 35 years ago, and he said, if you want to understand the deepest secrets of the cosmos, there are 4 steps. First, explore the outer visible universe. Second, explore the inner invisible universe, the psyche. Third, explore the relationship between these two. And finally, from these 3, you can come to know the deepest secrets of reality. Now, I want to begin with quantum physics, which is my field, my original field, and speak a bit about the work of David Bohm, who was a close colleague of Einstein's. And he defined this term, the Holomovement, which we'll unpack a little bit. But he said the cosmos is a single unbroken wholeness in flowing movement in which everything is connected to everything else. So he's speaking really as a scientist, but a scientist deeply informed by the spiritual traditions. So Bohm was a pioneer in quantum physics. He was a close colleague of Einstein's, as I said, and they both challenged the standard Copenhagen interpretation of quantum mechanics or quantum physics. Because, as Einstein famously said, God does not play dice with the universe. And this standard interpretation of quantum mechanics gives a statistical description of reality. And both Bohm and Einstein felt that the statistical nature of this interpretation does not mean that nature itself is statistical. There's something deeper going on, which our scientific instruments are not able to pick up. And so in 1952, Bohm did the impossible. He reformulated quantum mechanics based on non-locality, based on the idea of the fundamental interconnection of the cosmos with itself, which is what quantum physics was revealing. But Einstein didn't like it. because it implied this deep interconnectedness, which, according to Einstein, this should not happen. And he famously dismissed non-locality as spooky action at a distance. And basically what non-locality means in quantum physics, if you have two particles or photons that are entangled, even if they're several light years apart, if you make a measurement on one, it immediately determines that same state of the other particle. And for Einstein, that can't be, because nothing can travel faster than the speed of light. And so if you make a measurement on one and they're a few light years apart, it should take a few years for this other one to even know that that measurement was made. But that's not what quantum physics shows. Quantum physics shows an immediate, instantaneous connection, even by from these distant particles or photons. And so Einstein said, that's too weird, spooky action at a distance, or spukhafte Fernwirkung in German. Okay, so Bohm reformulated that experiment and gave an experimental design for actually testing this in the laboratory. And his quantum theory, Bohm's theory, inspired physicist John Bell, who tried very hard to get rid of non-locality. Like Einstein, he didn't like it. He spent 12 years, and he finally realized it can't be done. And by his own account, he said that Bohm's work led him to realize non-locality is foundational to the nature of reality. And so that led him to develop his famous Bell's theorem, which some of you may have heard of. And so that led to a whole series of experimental tests, which began in 1972 with John Clauser and then continued with Alain Aspect in 1982, which is when I first got enthused about this, and I've been tracking it ever since. And then in the 2010s, Anton Zeilinger and his colleagues. And these three physicists shared the 2022 Nobel Prize for this experimental work, which consistently showed that quantum mechanics was validated, that non-locality, or this sometimes called quantum entanglement, is real and experimentally supported. So the bottom line is, 70 years after Bohm's paper, is that non-locality is real. Einstein's dreaded spooky action at a distance exists, and it's actually the foundation today for the second quantum revolution. Now, I just want to add, they sometimes call this quantum entanglement. You may have heard of that. I don't like the term, because a better term would be quantum communion, or even better than that would be what Thich Nhat Hanh calls interbeing. It's not a tangle. It's not a jumble. It's a cosmic harmony of everything being foundationally interbeing with everything else. That's the true nature of the cosmos we live in. And in my view, these experiments are the strongest scientific experimental validation we have today of this inherent interconnected oneness of the entire cosmos. So it's really a profound breakthrough with profound mystical and spiritual implications. Now, David Bohm was also not only a major quantum physicist, but he was a real pioneer of science and spirituality. He had extensive, deep dialogues with spiritual masters like Krishnamurti, the Dalai Lama, and others. And he really strove to unify science and spirituality. And in that process, he developed his innovative theory of the implicate order, which is the science of the invisible realms, as a counterpart to the explicate order, which is the science of the physical universe. And this became Bohm's answer to those first two steps of the Dalai Lama's schema. And then he later developed what he called the Holomovement, and what I call the Internet of the Heart, as an elegant formulation of the intricate dynamic relationship between the implicate and the explicate orders, between the visible and the invisible realms. And this then relates to the Dalai Lama's third step in the schema. Unfortunately, Bohm was largely ignored in his lifetime. As Oppenheimer said at one point, if we can't prove David Bohm wrong, then we must all agree to ignore him. Astonishingly unscientific. Unfortunately, these things do happen. It's what I call the solitude of genius. Bohm was so far ahead of his time that none of his contemporaries could really go there with him. Now, Bohm was also way ahead of his time in this regard. He said that normal science tries to basically analyze all of reality in terms of two components, energy and matter. And of course, they're linked by the famous equation E equals mc squared. And Bohm said, no, that's not the whole story. Consciousness is also a foundational element. Matter, energy, and consciousness are the three foundations of reality, and each of them enfolds the other two. Nowadays, that's more recognized, and there's a whole emerging science of consciousness and many research studies and many different kinds of new paradigm studies. But 50 years ago when he proposed this, he was, again, way ahead of his time. And so he talked about the explicate and the implicate order. And the explicate order is that subset of reality that we can directly perceive, we humans, that our five senses plus the mind can directly comprehend. The implicate order is all the rest of reality. Now, when you first hear about this, the explicate order is essentially the visible, physical universe. So it seems like it's the primary reality. It's 100 billion galaxies, each of which has something like 100 billion stars. That's a big ticket item, right? And the implicate order just kind of feels like some ethereal energy field or something floating around. But for Bohm, it was precisely the opposite. He said the explicate order, that gigantic cosmos of a billion stars, is like the foam on the waves of the ocean. It's an ephemeral surface phenomenon, whereas the implicate order is the ocean itself. So the explicate order is basically a consequence of the implicate order, which organizes everything that becomes manifest. I'm going to skip over these two slides. That's a little more detail about the nature of the explicate and the implicate order. But the key lesson here is that a hidden order may be present in what appears to be random. This is really important. So, for example, in the quantum physics that gives a random process with different probabilities of different outcomes, Bohm and Einstein were saying, yeah, that's fine, but that doesn't mean that nature is random. There's a deeper underlying order that can't be observed by our scientific instruments, and therefore we can't describe in our current scientific theories. So this was a key lesson for Bohm. Now, this implicate order is hidden. We don't see it, nor do our scientific instruments see it. But it's present everywhere, visible nowhere. It extends throughout space and time, but also beyond space and time. It represents the unseen, that which is not directly perceptible to our mind and five senses or to our scientific instruments. And it has multiple levels, which Bohm called super-implicate orders. And they interact with the physical universe. So you have this sort of cascading downward from the implicate orders down into physical manifestation, and then physical manifestation injecting into the implicate order. So you have this kind of verticality, which contemporary science doesn't recognize and only focuses on that bottom plane of the physical reality. Now, what is this holo part of the Holomovement that Bohm spoke of? And from recent, the last 30 years or so, it is recognized that reality has this holographic or fractal structure. Now, don't worry about this equation here, but I just want you to, because you don't need to understand the mathematics here. All you need is an eye for beauty, and you'll follow this. But the simplest example of the holographic reality, or the fractal structure of reality, is this mathematical plot called the Mandelbrot set. Now, you can see it's a very simple equation there, right here. And you may remember, like in high school algebra, when you had a little equation, y equals x squared, and you would plot out the points, and you would get this beautiful parabola like that. Well, this equation is the same thing. It's just in the complex plane. It's more complex. But it's still, when you plot the graph, this is what you get. This very interesting looking object called the Mandelbrot set. And to give you an idea, I'm going to zoom in over here on the left side. We're going to kind of blow it up so you can get a sense of what this thing, again, all we're looking at is the plot of that formula, right? So it's a purely mathematical object. And as we zoom in, again, I'm going about 10 times magnitude each time. And now if I zoom into the center of there, that little pinch point, we get this. And if I zoom in into that little oblong here at the center, we get this. And then if we zoom into that star structure at the center, we get this. And if we zoom into that black dot at the center, voila, we find an exact replica of the original. This is 136 million times smaller, but it contains all of the same intricate, fine structure. And if you zoom into all of its little boundary areas, you'll find that it also contains these embedded miniatures within itself. So in science, these are called nested sets of self-similar structures. But I want to suggest it's really a modern scientific discovery of an ancient principle in Hermeticism called the principle of correspondence, as above, so below, as within, so without. Microcosm replicates the macrocosm. Now, you might say, okay, that's all great, but where's the practical application? Well, the fact is, it's all over the place. In the natural world, these fractal structures are everywhere. Take a fern. One leaf of the fern has the same structure as the whole fern. And then there's this beautiful example of Romanesque broccoli, if you've ever seen it. And each of these nodules here is a replica of the entire thing. And each of the tiny little nodules on it is yet another replica on a smaller scale of the entire broccoli. Here's a closer image of the surface of the broccoli. So it has this quality of each part is a miniature replica of the whole. Similarly with tree branches, they have this nature of kind of branching into these patterns with a similar structure at every level of branching, from the trunk all the way to the twig. So that if you, for example, were to cut this tree this branch off right here, then this becomes like the trunk, and these are its branches. This is the structure. Sometimes it's called scale invariance, because no matter what scale you look at, whether at the trunk or the twig level, the same basic branching process appears. Now, we also have this in lightning. So lightning also has a fractal structure. And this is a picture of the human eye. So at the very top, you can see the lower part of the pupil up there, and then this is the iris, and these are the blood vessels in the eye. The entire circulatory system of the human body also has this scale invariance, this fractal structure. So also do the trachea and our lungs. So these holographic or fractal-like patterns, they're part of our living being right there in our physical body. So this is not some abstract thing. It's part of the structure of creation itself. And then this photo, which we also saw in that earlier video, on the left side is an image from electron microscopes of neurons in the brain. Scale is a few microns. And on the right side here is astrophysicist's conception of the universe. And you can see a very clear correlation there in the structure, as above, so below. So now, everything I've said so far is pretty much accepted in quantum physics and contemporary physics. But in analogous manner to the mathematical fractal, I want to suggest consciousness itself has a fractal structure. As Rumi says, the secret turning in your heart makes the entire universe turn. And so we have this video now to show you what the interiority looks like. Can you play it? So what we're going to do is we're taking a deep dive again into this mathematical object. And you can see, as we do so, the unbelievable complexity and intricacy of this structure. So I want you to imagine now that what you're looking at, although it's just the plot of a mathematical object, is you're actually looking at the interiority of reality and the interiority of this process that David Bohm called the Holomovement, and I call the Internet of the Heart. And what you'll see in a moment is one of those miniature versions is going to come up. Now, this particular video goes for 175 orders of magnitude. And you can see it's complex, intricate, and incredibly beautiful. And it almost looks like, some computer scientist, dropped acid or something and then tried to represent the visions they had in some computer algorithm or something. But this is merely the plot of that mathematical graph. But if you watch here for a moment, you'll see that little seed is going to arrive in just a second, coming right out of the center and going off to the left side. And there it is. You can see that little fractal going off. So again, those same similar seeds are buried throughout this video. So how did that happen? I'm trying to get to my slideshow again. Hello? Okay. I'm just trying to return to the slides. There we go. So basically, the process we've just seen, on the right-hand side, you can see from the mathematical infinite, we have one formula, and we get this mathematical fractal. I want to suggest that creation works the same way. We have the spiritual infinite, we have a spiritual seed, and that creates the spiritual reality. And the example from that in the Bhagavad Gita, Krishna, speaking as God, basically says, I am the original seed of all of existence. My seed is found in all beings. In John's Gospel, we find the same thing. In the beginning was the Logos, the Word, and the Word was with God, and the Logos was God, and through the Logos all things were made. So I want to suggest that all the spiritual traditions of the world have this. From the absolute, then there's a particular spiritual structure that is like the seed, and each of that creates one of the different major world religions. And so I want to conclude with Indra's net. Indra's net is an image from the ancient Buddhist and Hindu cosmology of a whole network of jewels, each of which contains all the others. And so that is a metaphor for the nature of reality between the one and the many. So I'm going to, bottom line here is that each of us can access the full infinity of divinity through our own hearts. So you are not just a drop from the infinite ocean. You are the infinite ocean contained in a single drop. And we see that across the religions, in the scriptures. I'm going to skip over these slides. I want to conclude with this slide here. This was published on the front cover of Nature in 2014. It's a composite image of the nearest 100,000 galaxies to our own. And it says, you are here, right? That's the Milky Way. Every dot on this graph is a galaxy, and there's 100,000 of them that are plotted, and the threads, each thread is the movement of that galaxy through space. And even in the Nature article, they noted that they're converging on a structure that looks very much like a heart. Now, of course, this is a two-dimensional object, but to give you an idea of its three-dimensional structure, there it is. Those are the lines of that Laniakea supercluster, and look how they precisely map onto the human heart. So the moral of this story is, if you want to go to the infinite source, whether outwardly through scientific exploration or inwardly through spiritual inquiry, you have to go through the heart. Thank you very much.